Hello, honors, Algebra 2. We are going to go through our measures of central tendency notes. So that is going to be on page 22. You do need your graphing calculator. So you need one of these types of calculators to help you with the work today. So get one either between like you or the person sitting next to you, at least so you guys can get the practice in, because we're going to be using these to help us to be doing the math today. So measures of central tendency is something that you guys are very familiar with. So a measure of central tendency is a value that describes the middle or the center of the data. One of our most common measures of central tendency is the mean. So the mean, as you guys already know, is the sum of all data values divided by the number of values in the data set. So divided by the number of values in the data set. The mean is typically our best representation of the data, and that's typically what we want to look at when we're looking at like a data set and kind of analyzing it. The only time the mean is not the best representation is when there's an outlier. So what I mean by that is if I gave you like a data set and I said, okay, 87, 88, 88, 89, 34, and 91. If I looked at that and I calculated the mean, which would just be adding those together, 87 plus 88 plus 88 plus 89 plus 34 plus 91, which gets me 477, divide by 6. My mean there is 79.5. Now, why is that? Well, the reason is that 34. That 34 is what we call an outlier, and it's skewing the data, so it's causing the mean to be significantly lower and not the best representation of the data. So when we don't have, like when there is an outlier, which there is, instead what we would want to look at is the median. The median is the middle. So to find that, you'd have to organize them from least to greatest, and then look at the middle numbers. Now, my middle numbers are the same, and so my median is 88. And so 88 in this case is a better representation of the data than 79.5. Like no other numbers are even close to 79.5. And so that's when the mean is not the best representation. But typically we care mostly about the mean and that being our representation. Okay, another thing that we look at are different measures of variation. And a measure of variation is a value that describes how spread out a set of data is. So there are two things that we look at, and they're actually pretty related. In Algebra 1, you guys might have done this by hand, but we're going to really just be doing it using the calculator. But if you were to do this by hand, to find the variance of a data set, you would first find the mean of the data. So find the mean of the data. Once you found the mean, you would then subtract the mean from each value. So if we were like circling back to this problem, for every value, you'd go 87 minus 79.5, 88 minus 79.5, 88 minus, and so on and so on and so on. Then once I've done that, I would square each difference. So whatever I got for like once I subtracted, I would square that. So raise it to a power of 2. And then last step to find the variance, I would find the mean of all the squared values. Find the mean of all squared values. So I'd like subtract from these, and then I'd square them, add those values together, and then divide by 6. And that gets me the variance. Now the standard deviation basically plays off of the variance. And so the standard deviation, you take all of this, like what you get in the last step, and then you take the square root. So the standard deviation is the square root of the variance. So standard deviation, when we have a lower standard deviation, it indicates that the values are closer together. And a higher standard deviation indicates that the values are more spread apart. So it doesn't tell me anything about like what the actual values are. So it doesn't tell me anything about the numbers. It just tells me how close together they are or how far apart they are. So what I mean by that is if I gave you set A and said, okay, so set A, you have 1, 8, 15, 21, 24, and 42. And then set B, you have 88, 89, 91, 91, 92, what did I do, 6, and 93. Even though set A has a lower, like the values are less, it's going to have a higher standard deviation. The range of data goes from 1 to 42, whereas the range from set B goes from 88 to 93. So the range here is 5, whereas here the range is 41. So set B is going to have a lower standard deviation. So again, it really tells us nothing about the actual values. It just tells us how like close they are to each other or how spread apart they are. So we're going to do this math to find the standard deviation. And actually, we're going to talk about how to find the mean on the calculator. So I'm going to use actually these values. And then, so you guys do need your graphing calculator. So get that out. And then we're just going to go through the steps. So the first step, I'm going to do it on the calculator, and then I'm going to write it down. If you like need to write it down in a different way because maybe your calculator's a little different, go ahead and write it down a different way. But for the most part, it's all going to be the same. So the first thing you're going to do is you're going to go into your calculator. You're going to press stat. And the first like thing is edit, and then the first one is edit. That's where you want to be, and you press enter. Now, I already have like data values in there. So if you have data values in, you can just press delete, and it should delete all of your data values. Okay, so that's going to be the first step. So I'm just going to write that down. My first step is to press the stat button. So the stat button is 3 columns over, 3 columns over, 2 rows down. So press the stat button. Edit, and then edit. So again, we press the stat button. We were in the edit category and then the edit subcategory, and then we're going to press enter. And so now we're just going to enter our data values into L1. So make sure you have L1, and so I'm going to enter the data values into L1. So I'm going to enter these values, and so I'm going to do that. So I'm just going to go 1, press enter, 8, enter, 15, 21, 24, 42. And so I'm just going to, again, double check because, like, honestly, the biggest mistake with this is just you typed in a number wrong. So 1, 8, 15, 21, 24, 42. We're good. So then you're going to second quit. So you're going to quit out of that. So quit. If you need to write second mode, write second mode. And then once we do that, so once we're quit and we like back at our normal screen, we're going to go back into stat. And now we're going to go scroll over to edit. And the first one is one var stats. We're going to use that one. So I'm going to press enter. Now you may have like already a list has come up. Great. Then you're done. If not, and you have my screen, we have one more step to do. So I'm just going to write my fourth step. Press the stat button. And now instead of being an edit, we're going to go to calc and then one var stats. So that's where I'm at right now. Now for me, I'm just going to press enter like a few times, and then it's going to give me this list. Once you're at this list, then that's what you want. Like this is what you're looking for. So for mine, I have to go down to calculate. Okay, so what do all of these things mean? So my first one, the X bar, that's giving me the mean of my data. So my data here, if I were to have added those up and divided by 6, I would have gotten 18.5. So that's going to be important for us. The mean is X bar. And then the standard deviation here is like that circle with a little line over it, 13.02. So standard deviation is that like circle with the line over it. Now it also is giving us a lot of other stuff too. Like the sum of X is giving us the sum of all of those values, which could come in handy. N is telling us that there are 6 values. Like min is telling us like that's the minimum value. The minimum value is 1. Q1, if you guys remember, like in Algebra 1, you guys made box and whiskers, and it's the median of the lower quartile. And then 18 is the median. 24 is the median of the upper quartile. And then my max value is 42. So it gives us a lot of information that we do like definitely care about. But really in this section, all I care about is the mean and then the standard deviation. So what I want you guys to try is just right now on your own, plugging into the calculator, set B, and then get the standard deviation. So in this case, my standard deviation was 13.02. So what I want you guys to do is go through, try it on your own, and get the standard deviation of set B. So pause me here and come back. Okay, so you should be coming back. I'm just going to go over it one more time since I'm not here to walk around and help you. But hopefully you're just coming back to check your work. So stat, edit. I'm going to just press delete, 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 to delete like all of my stuff. And then I'm just going to type in 88, press enter. So if you want to see like my whole calculator. So 88, 89, 91, 91, 92, 93. Double check that I typed everything in right. I think I did. So now that it's in there, I'm going to quit. I'm going to go back to stat, over to calc, one variable statistics, and then I'm just, to get to calculate, I just press enter, enter, enter. And then I'm going to press enter, and then it's going to get me my list. So the standard deviation here was equal to 1.699, so that's 1.70. So as we like guessed, the standard deviation is significantly lower in set B than in set A. So that's really like the math that you guys are going to be doing today and using today. So as long as you know how to do it in your calculator, for the most part, this is pretty straightforward. So let's turn the page and let's do the classwork. I'm going to zoom back in. So what I would like you guys to do is just pause me or like, well, listen to what I'm going to say and then pause me and try it on your own. So for 1, 2, and 3, what I want you guys to do using your calculator, get the mean and the standard deviation. And I'm really not going to do much work here besides just tell you what I got with my calculator. So I do want you guys to pause me at this point and see, like, do it on your own. Switch it back and forth with your partner if you need to, just so you all get that practice in. And then come back and check your work. Okay, so you should have paused me at this point. And then you should be coming back to check your work. Okay, so I put my answers in for each problem. So the mean of number 1 was 77.8. The standard deviation was 14.32. If you did not get these and you need help with your calculator, ask somebody around you or wait and I can help you guys on Friday. But just make sure you're getting that practice in. So let's look at 4. So 4 is a little bit different, and there's multiple ways that you guys can approach this. But what it's giving you is a frequency table. So it's not saying, like, we can't just put 93, 91, 90, 87 into our data set. What it's saying is that 93 appears 3 times, 91 appears 5 times, so on and so on. So it's just asking us to find the mean. So you can do that in your calculator if you want to, or you can do it like kind of by hand as well. I don't always like to type it into my calculator, like into the stats one. So I actually just did this one kind of by hand. So I would have done, if I were just doing this like by myself, I would have done 93 times 3 because it appears 3 times, plus 91 times 5, plus 90 times 2, plus 87 times 5, plus 84 times 3, plus 75 times 2, and then plus 62, all divided by, and so I need to add up like how many of these showed up. So to do that, that would be 3 plus 5, so 8, 10, 15, 18, 20, 21. So all of those like data values added up to be 21. So I'm going to divide by 21. And then I'm just really going to do that math in my calculator. So in my calculator, I would just start by doing the top first. So 93 times 3 plus 91 times 5, 90 times 2, 87 times 5, 84 times 3, and then 75 times 2, and then plus 62. And so when I added those all together, I got 1813 on top. Okay, that was a weird 3. Divide by 21, and that gets me a mean of 86.33. If you wanted to plug it in and do stat and like type all the numbers in, that's fine. Just make sure when you type it in, you type in 93 3 times and 91 5 times and so on and so on. Okay, so let's look at 5. 5 says, which number would you remove from the list below to get a smaller standard deviation? Remember, a smaller standard deviation means the numbers are closer together. So take a second, look at those values and see which one would you remove to get a smaller standard deviation. Okay, you should be coming back. You should have thought about it, and hopefully you thought about 34. 34 is way off from all the other data values, which it's considered an outlier. And so what it's going to do is it's going to make the standard deviation much larger versus if we had just taken it out. Okay, so then the last one we're going to do is 6. A freshman class of 220 students raised $1,200 for a charity. The senior class of 175 raised $700. What's the average for both groups? The only thing that's tricky here is what it's asking you to find. It's asking us to find what's the average for the groups, not what's the average for each person or each student. And so instead of dividing by like 220 plus 175, we're just going to divide by 2 because the number of groups are 2. So 1,200 plus 700 gets me 1900. Divide by 2 gets me a mean of 950 per group. So again, because it's both groups, you're going to divide by 2. And that's it. So that's it for our notes for today. Make sure you guys, if you guys have any questions, you can either email me or talk to me on Friday and we can go over whatever you need to. But other than that, have a great rest of your day and I will see you guys soon. Bye, guys.